Now, in today's lesson, we're going to be talking about the quotient rule. In the previous lesson, we talked about the product rule. The product rule just meant that we had two functions that multiplied. How would we find that derivative, right? That was the product rule. For the quotient rule, this is when you have two functions that are dividing. How do you determine that derivative? Okay, so in this example, what we have is a rational expression. Okay, it's a polynomial over a polynomial. But in general, you've got u over v, okay, and you want to find its derivative, so you want to find what it is primed. Here's the formula. It's v squared on the bottom, and you've got v u prime minus u v prime. That's the formula. So you're basically taking the denominator squared, okay, you're squaring the denominator, you're lifting that denominator as is to the top, multiplying by the derivative of the numerator, then subtracting the reverse combo, where you got the numerator left untouched, and you've got the denominator primed. That's basically the formula. Let's do this. Let's label the numerator as u, denominator as v, and so u prime is going to be 2, v prime is going to be 3, okay, and then all I have to do is plug it into that formula, provided that I've remembered that formula very well. So here we go, dy dx equals, on the bottom, v squared. V is this, so I just have to do v squared. Then on the top, I go 3x minus 4 with v, and I multiply by u prime, which is 2. Then I subtract u, which is 2x plus 5, and I multiply by v prime, which is 3. That's the formula, and then all you have to do is apply distributive property on the numerator and collect like terms. 6x minus 8 minus 6x minus 15. Six x take away 6x will cancel, and end up getting negative 23, all over 3x minus 4. Ladies and gentlemen, that is the quotient rule. Let's apply it to another example. Now, we've seen an example like this before. What you want to do is determine the points, this means xy, coordinates xy, where the function has a slope of negative 3. All this means is the derivative is negative 3. So you have to find the derivative first. Now this is a quotient, so I can apply the quotient rule. I'm going to call the numerator u, I'm going to call the denominator v, and I'm going to apply the derivative to each term. So I've got u prime v prime. The derivative, dy dx, is going to be v squared on the bottom, v is lifted, u prime minus u v prime. That's it. Let's do this. So what do you get? V is 4x minus 3. I also have to write that on top. And then I write u prime, which is 1x, or just x. Same thing. Minus u, which is half x squared plus 11, times v prime, which is 4. Again, I apply distributive property, and I get 4x squared minus 3x minus 2x squared minus 44. And I end up getting, after collecting like terms, 2x squared minus 3x minus 44. Now, you must ask yourself, can I factor the top? Negative 88, probably not, but one important key note is that the slope is negative 3. What that implies, let me do that a little nicer. What that implies is that the derivative itself can be set to the value of negative 3. When I multiply both sides, what I'll have to do here is I'll have to FOIL. I've got two brackets set together. So I'm going to have to FOIL that. I'm going to get 16x squared minus 24x plus 9. And now what I'm basically getting is a quadratic equation. So let's apply that 3 inside, distributive property, right? Plus 76x minus 27. And now what I will have to do is I'll have to bring things over to one side. I'm going to choose to bring things over to the right side because that will produce a positive x squared coefficient. So I get 50x squared equals negative, 50x squared minus 79x, because if I bring this over, that positive 76x becomes a minus 76x. And then when you tack that onto negative 3, you get negative 79. And then I've got negative 44 plus 27. Negative 44 plus 27. What that turns into is negative 17. So now I've got a quadratic equation. What I'm going to do is I'm just going to plug this into the quadratic formula, and hopefully this doesn't look too bad. Now if you can't remember the quadratic formula, it's negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so negative b in this case is going to be a positive 79 because b itself is negative. 79 plus or minus square root of 79 squared minus 4 times 50 times negative 17 all over 2 times 50, which is 100. And what do you end up getting here? Let's see. 4 times 50 times 17, 3,400 plus 79 times 79. Okay. And then square rooted. I'm doing this all on my calculator. So inside the square root here, I end up getting a 9641. Okay, be sure to check that. And then you end up getting decimals here. So let's do it to 2 decimal places. Why not? Plus or minus 98.2, or let's say, sorry, 19 all over 100, and then this will lead to 2x values. Once I get the 2x values, I'll have to plug them back into r of x to get the 2y values, and then I am done. I've got my point. Let's do a word problem, shall we? So we've got a chemical cleaner from the factory. It's accidentally spilled into a lake, and the concentration of cleaner, C, in grams per liter in a stream that runs from the lake was modeled by this function. So you get a concentration in grams per liter, and it's basically a quotient function. Okay, it's got a it's dividing, so you could apply the quotient rule. So determine the rate of change of concentration after 40 hours. After is instantaneous. So it's basically saying get derivative, or slope at t equals 40. So first, what you're going to do is you're going to do the derivative. So I'm going to do u equals 28t, v equals 0.7t squared plus 6, and I'm going to apply the derivative to each term. 28, v prime is 1.4t. And then I'm going to do my derivative function. So in this case, I'm just going to call it c prime. It just makes life a little easier. And I'm just going to do, let's see, v squared. So all of v squared. And then v comes out on top. And then u prime is 28. Minus, and then v prime is 1.4t, and then u is 28t. So keep in mind you have two options here. One is you plug in 40 straight into this function and you get your derivative, c prime of 40. The other one is you can simplify first, then actually plug in 40. It really doesn't matter because all it's asking for is the derivative at a certain time. But if I just distribute this in, just for argument's sake, I get 19.6 t squared plus 28 times 6, 168, and then 1.4 times 28 minus 39.2 t squared, 0.7 t squared plus 6 all squared, 19.6 minus 19.6 minus 39.2 is negative 19.6 t squared plus 168. And now all you have to do is plug in 40 and you are all set. Actually, I made a little error, right? Because 40 hours is a different unit than the t in the question. T in the question is in days. So what I would have to do is not plug in t equals 40, but I have to plug in a conversion, right? So a converted time value. So not t equals 40, but t equals 40 times 24 over, no, I was right before. 1 day over 24 hours. Now, the reason why I'm choosing this conversion factor is that the h's for hours have to cancel, and they end up getting in units of days. So it's really 40 over 24. 40 over 24 can be reduced to 20 over 12, or 10 over 6, or 5 thirds. 5 thirds of a day. So actually, I have to plug in c prime of 5 thirds, and I will get the value, whatever that is, and that's the answer to that question. And then what I would do, honestly, is I would say, you know, a therefore statement, the rate of change of concentration of the cleaner in the stream is this much in, you know, grams per liter per day after 40 hours. That's what I would say. So thank you so much, and peace out, guys.